This is the video for Introduction to Spatial Analysis, Lab 12. And this we will be working with vectors and rosters. So we're going to want to open up our exercise 12 APRX file. And then we want to go to the vector work to begin with, map. And then the first thing is we want to set the working environment, so we can go to Analysis, Environments, and then we want to have our current and Scratch workspace set to exercise 12 GDB, and then we want our processing extent to be counties, and then press OK. So we want to do some aspatial queries first, so we can go back to map. We can drag geology up so we can see the symbology for the geology layer, and then we want to go select by attributes, and we want to open the attribute table for geology. So we want our input row to be geology, we want selection type to be new, and we want period is equal to Silurian, and then we can apply. And 154 of those should be selected. Now we want to clear selection and select by attributes again, and then we want to have the same setup, but we want to add and type is equal to limestone, and then apply. And we should get 41. And we can clear again, and we can change it to or limestone, and we would have 336 selected. Now we want to perform spatial queries, so we can clear our selection, select by attributes, and then towns, new selection type. We can remove our old SQL. We can add clause where name is equal to Charleston, and then apply. And now we want to perform the spatial part, so we can go to select by location. We want our input to be polluters, our relationship to be within a distance, our selecting features towns, change this to survey miles, and then 10 miles, and then apply. Now we want to select polluters within a half a mile of an interstate, so we change our selection type to select from subset. We change our selecting features to interstates, and we change 10 miles to half a mile, and then apply. And we can also close out our geology attribute table, and we should have 51 features selected. It will say 52 because it's also including Charleston as one of the selected features. So the next thing we want to do is vector spatial analysis. So we can clear our selections again. We can go back to select by attributes, change it back to geology, new selection type, and we want to add type is equal to limestone, and we can apply. So if we wanted to export all of the limestone features, we would right click on geology, go down to data, export features, and we want to name this limestone. And OK. And that'll export all of the limestone features that we can see in the purple. Now we want to use the clip tool to find all the towns that are built within the limestone layers. So we can go to Analysis, Tools. We can look up Clip. Select the clip. And then we want to set our input feature to towns and our clip features limestone. And we want to rename this towns in limestone, and we can run. And then this will extract all the towns built within the limestone layers in the red dots that we see. Now we want to have all the towns that are within limestone and then within 5 miles of an interstate. So we can use the buffer and the clip tools to find these towns. So we can go to Tools, we can look up Buffer, click on Buffer. We want our input feature to be interstates. Our output feature class we want to call interstate buffer. We want linear units. We want to set this to US survey miles, a distance of 5. We want side type full, round, planar, and we want our dissolve type to be into a single feature. And then we can run this. Now we can go back to our clip tool and we can set our input features towns in limestone, and we want our clip features to be interstates buffer. And then we want to rename our output to towns underscore ext, and we can run. And here we can see all of the towns within the 5-mile buffer. So next we want to generalize the geology, so we want to have we want to make all the features of geology the same age and put them all into one feature. So we can use the dissolve tool. So if we go to Tools, Dissolve, we want our input feature to be geology, and we want to rename our output feature class to geology age. We want our dissolve field to be period, and we don't have to change anything else. And we can run. And if we wanted to change the symbology of this, we can right click geology age, symbology, and then we can change this to unique values, change it to periods, and then we would have to add we can add all of the different ages to this. Pull this up here. Here we can see the ages of all of the different rocks over here. So we want to work with the dissolve tool again to create one feature class for the interstate. So go back to Tools. If we go to Recent Tools, we can find Dissolve. And then we want to have so we want our input features to be interstates. our output feature class, we can call interstates dissolve. We want our dissolve field to be signed 1, and then we can run. And that'll create one feature class for all of the different interstates. Before we move on to rosters, we can perform one more query in vector work. So we want to clear all of our selections that we have made, and we want to go to select by attributes. We want to change our input rows to towns. We want to set our field to population is greater than, and we want to set this to 14,000, and we can apply. So now we can right-click our towns in the contents pane, go down to data, we can export this feature, and we can call this large underscore towns, and we can press OK. So if we unselect everything else, we can see the 10 largest towns in West Virginia in red. So now we want to create a Thiessen polygon, so we can go to Analysis Tools, and we can look up Create Thiessen Polygon. We want our input feature to be large towns, and we want to call our output feature class T underscore polys, and we want our output field to be all fields, and we can run. Once this is run, we can see it's bigger than the extent of the state, so we can change this by using the clip tool. So if we go back and we go to clip, we can set the input feature to t-polys, and we want the clip features to be counties, and we can call this t-polys clip, and we can run. Then we can close that, and then if we uncheck our original t-polys, we can now see the new polygons are clipped to the extent of the county boundaries. We can now calculate the area. So if we go to add geometry attributes, and we use calculate geometry attributes, we can set the input features to t-poly clips. We can set our fields to area. We want our area unit to be in square US survey miles, and our coordinate system we can set to the current map, and we can run. And then this will create the area in square miles for each of the different polygons that we created. Now we can go and work in the roster work. So if we close everything out, we go to roster work, and we want to set the environment again, so we can go to environments. Our current and scratch workplace we want to set to exercise 12. We want our processing extent to be the same as LC, so click extent of data in all layers, LC, and then we can look up mask in the search bar, and we want to set our mask. We go into counties, the exercise 12 database, and we want to find county sub, and okay, and then we can press OK to save all of our settings. So for now we can still use Euclidean distance, but in later software this will change. So we can go to tools, we can look up Euclidean distance. We want our input feature to be river, so we'll have to find that. So if we go to folders, this will open up the exercise 12 database, and we want to set our input to rivers and press OK. And then we want to call this river underscore distance. And we want to set our output cell size to 30. And we can run. Now we can also do this in the distance accumulation here, but I will not show that because Euclidean distance is still working. But you'd also be able to do a distance accumulation to get the same result. So we want to go back to geoprocessing, and we want to find the roster calculator. And make sure we're using the spatial analysis version. And then we want to set our river distance to less than. Let me find our less than operator, and then a 5,000. And we can call this river distance, and then BI, and then we can run that. And this will set the operators to a 0 and 1 value. We can clear this operation, and we can set our land cover. We want to enter our land cover, so double click, and then the equals, and then 41, and rename this to land cover binary, and run. And then we want to set the elevation binary, so elevation less than 500, and rename this elevation underscore binary, and run. So now we want to add all of these binary rosters together, so we can find the binaries we created, and we can double click them and then multiply them by each other. And we want to name this model, and we want to run. So any areas in red are areas that meet all of the criteria, and areas in gray are areas that did not meet all three of the required criteria. The final step is we want to do some terrain analysis. So we want to create a hillshade model from the digital elevation model in our roster workspace. So if we go to geoprocessing and we look up hillshade in the spatial analysis, we want to set the input roster to elevation, and our output roster we want to call HS for hillshade. We don't need to change anything else, and we can click run. And then this will create a hillshade model for this area that we've been working in. We can also create contour lines. So if we go back to geoprocessing and we look up contour in spatial analysis, so we want the spatial analysis tools, not the 3D analysis tools. We can set our input raster to elevation. We can rename our output feature to contours. We want our contour interval to be 50. Base contour 0, Z factor 1. And then we want it to be a contour type is stay as contour. And we can run. And if we unselect everything else so we can just see the contours, this created a contour map in 50-foot intervals for the state using the digital elevation model. And that is the end of exercise 12.